In terms of what we've seen, this should make sense. If m of t equals df dt and n of t equals df dy, then dm dy is df dt derivative with respect to y, which is the second partial of f with respect to y and t. And df dy has a derivative with respect to t, which is second partial of f with respect to y and t. They have to be equal. So whenever we have this condition that the y derivative of m is the t derivative of f. In that case, we have an equation m dt plus n dy equals 0, which just means that df equals 0. If we can recover the f function, then setting that equal to constant gives us a solution to our differential equation. Now, if you make sense of all these ideas and how they hang together, this is a pretty slick method. So this means that if we see something times dt plus something times, that should be dy over there. I think I've written it as dt. No good way to change that except to kind of smudge over it. I apologize for that. Now, if this is our m function, and whatever's in front of the dt will be the derivative of f with respect to t. You can review previous clips and look at your text and see why that's the case. Then my is what? Well, square root of y, derivative is 1 over 2 square root of y. E to the t cosine y has y derivative, negative e to the t times the negative sine of y. I don't seem to be able to write a y without writing t instead. And the derivative of t with respect to y is just 0, so my is this. Your n function is t over 2 square root of y plus e to the t sine y. If you go back to where this all comes from, we see that the n function is whatever goes in front of dy. And remember, I'm very possibly reversing the roles of m and n in this equation. The principle is the same, and if you understand the principle, that won't make any difference. So the t derivative of n is what? Well, t over 2 square root of y has derivative just 1 over 2 square root of y. The derivative of t is 1. And the derivative of e to the t is e to the t. So this is e to the t sine y. So these things are equal, meaning that this equation came from some mysterious source function f, and if we can just determine what that source function is, we can solve the equation.